Welcome to what might be the most remarkable manufacturing facility on the planet. Nestled in central China lies BYD's colossal electric vehicle production complex, a sprawling industrial ecosystem that cost $12 billion to construct and spans over 3,000 acres. To put that in perspective, you could fit 1,700 regulation-sized soccer pitches within its boundaries. The facility's ambition matches its scale manufacturing capacity, designed to produce 1 million electric vehicles annually. But here's what truly sets this place apart. Every 30 seconds, a brand new electric car completes its journey down the production line and enters the world. This level of efficiency ranks among the most advanced anywhere in global manufacturing. Yet perhaps the most fascinating aspect isn't the machinery at all. It's the human element. This isn't just a factory. It's a functioning township where approximately 63,000 employees don't just work, but actually live. They can bring their families, who can also find employment within the complex. By creating this self-contained community, BYD has engineered something beyond production efficiency. They've built employee loyalty and retention into the very architecture of their operation. Today, we're taking you deep inside this extraordinary facility to understand how BYD achieves what seems impossible, completing a sophisticated electric vehicle every half-minute. We'll explore the technology, the systems, and the strategic thinking behind this achievement. And we'll answer a crucial question. Why was this particular location chosen for what has become the world's largest electric vehicle production base? If you find this exploration valuable, please subscribe to our channel to stay informed about developments reshaping the global economy and technology landscape. Now let's begin. The unlikely journey, how China became an electric vehicle superpower. The story begins in an unexpected place. 1995, when Chinese engineers assembled the country's first electric vehicle. At that moment, almost nobody took it seriously. The skepticism was understandable. China was still developing its conventional automotive industry, still catching up to established manufacturers in traditional combustion engines. The idea that this emerging market could leapfrog into advanced electric vehicle technology seemed far-fetched, if not absurd. Industry observers dismissed the possibility that Chinese electric vehicles could pose any meaningful competition to established automotive powers. Fast forward just over a decade, and the transformation defies belief. In 2008, China's entire electric vehicle market consisted of merely 2,400 units sold annually. Today, annual sales exceed 7 million vehicles. Let that sink in, a 3,000-fold increase in just 15 years. Since 2015, China has maintained its position as the world's largest electric vehicle market for 7 consecutive years, a dominance that shows no signs of weakening. But domestic sales tell only part of the story. Chinese electric vehicles have begun their global expansion in earnest. In 2022, China exported 680,000 new energy vehicles to international markets. Just 1 year later, that figure jumped by more than 77% to 1.2 million units. These vehicles now reach every inhabited continent: Europe, Asia, Oceania, the Americas, and Africa. Europe represents the crown jewel of this export strategy. In 2023 alone, China shipped 640,000 pure electric vehicles to European nations, representing over 41% of total electric vehicle exports. The appeal is straightforward. Chinese EVs combine competitive pricing with reliable quality, making them accessible to middle-class families across different markets. The enthusiasm is palpable. In Southeast Asian countries like Thailand and Singapore, customers have been known to camp overnight outside dealerships, waiting for the opportunity to purchase Chinese new energy vehicles. The secret behind this explosive growth isn't just innovation or investment, it's production velocity. Chinese manufacturers have mastered the art of rapid, efficient electric vehicle production at unprecedented scale. BYD, the quiet giant that overtook Tesla. Among China's constellation of electric vehicle manufacturers, one name stands above the rest: BYD. The company's recent performance tells a remarkable story. In 2024, BYD generated annual revenue exceeding $107 billion, surpassing Tesla's $97.7 billion during the same period. This wasn't a fluke or a one-time achievement. It represented a fundamental shift in the global automotive power structure. The momentum continues accelerating. By July 2025, BYD had exported 470,000 new energy vehicles in just the first 6 months of the year, a 132% increase compared to the previous year. Industry analysts project that, if this trajectory holds, BYD's international sales will cross the 1 million threshold by 2026. But BYD's leadership isn't content with incremental growth. They're thinking in terms of infrastructure, capacity, and global industrial dominance. This thinking led to the creation of the Zhengzhou Superfactory, a $12 billion bet on the future of electric mobility. Inside the megafactory, where scale meets precision, the Zhengzhou facility sits in the suburban outskirts of central China, occupying more than 3,000 acres of carefully planned industrial real estate. Construction began in 2021, and the development has followed a phased approach. Phases 1 through 3 are now fully operational, dedicated to complete vehicle assembly, from basic components to finished automobiles ready for delivery. Phase 4 introduces a fascinating strategic element, a dedicated semiconductor manufacturing facility operated by BYD Electronics. This chip factory isn't producing generic components. It's specifically designed to manufacture automotive-grade semiconductors that cover approximately 90% of the chip requirements for new energy vehicles. This includes critical components like IGBTs, or insulated gate bipolar transistors, and MCUs, or microcontroller units, that serve as the nervous system of modern electric vehicles. The next expansion is already underway. Over the coming 6 months, BYD plans to complete construction on phases 5 through 8. When this expansion reaches full capacity, the complex will solidify its position as one of the world's largest electric vehicle production bases, with the capability to manufacture at minimum 1 million new energy vehicles annually. But impressive statistics about scale only tell half the story. The real question is, how does this facility actually achieve the extraordinary pace of one vehicle every 30 seconds? The symphony of automation, producing a car every 30 seconds. The Zhengzhou Superfactory operates 16 fully automated production lines that run continuously, 24 hours a day, 7 days a week. From the moment raw materials enter the facility to the second a completed vehicle rolls toward its destination, nearly every operation is handled by advanced automation systems. Consider the stamping workshop, where the transformation begins. Large sheets of metal arrive at fully automated presses operated by robotic arms and industrial machinery. These systems rapidly transform flat metal into precisely shaped components: door panels, hood sections, structural elements. There's no human hesitation, no variable timing. The mechanical systems work with relentless consistency, each press cycle perfectly timed. Once stamped, these components don't wait for human handlers. Instead, they're automatically transported via integrated conveyor systems to quality inspection stations. Here, advanced blue light scanning technology examines each piece with microscopic precision, measuring dimensions to ensure they meet exact specifications. This matters enormously. Even a deviation of a few millimeters can compromise the integrity of the final assembly, affecting everything from door alignment to overall structural safety. Next comes the welding workshop, where the vehicle begins taking recognizable form. Hundreds of individual stamped components must be joined together to create what the industry calls a body in white, the complete vehicle frame before painting. Specialized welding robots handle this complex choreography, each programmed with exact coordinates and sequences. The precision required is remarkable. Modern electric vehicles integrate the battery pack into the structural design, meaning the frame must meet extremely tight tolerances to ensure proper fit and safety. Completed frames don't immediately proceed to the next stage. Instead, they're transported to a sophisticated three-dimensional automated warehouse, essentially a vertical parking system for car bodies, where they await their turn for the next production phase. Before painting, each frame undergoes a process called electrophoretic treatment, or e-coating. Despite the technical-sounding name, the concept is straightforward. The vehicle body receives an electrically applied primer coating that provides foundational protection against rust and corrosion. The entire process, remarkably, takes approximately 3 seconds. Robotic systems then apply sealant to critical joints before the vehicle enters the paint booth for its final color application. Then comes final assembly, the most intricate phase of the entire operation. Thousands of individual components must come together in precise sequence: windshield and window glass, the complete chassis assembly, the battery pack system, interior components, electronic systems, and countless smaller parts. The battery installation demands exceptional dimensional accuracy. The tolerances are measured in fractions of millimeters because even minor misalignment can affect performance, safety, and longevity. After complete assembly, every vehicle passes through what BYD calls the OK line, a comprehensive static testing station. Here, sophisticated diagnostic systems conduct thorough examinations of the vehicle's appearance, electronic systems, safety features, and overall quality. Only vehicles that pass every checkpoint are cleared to leave the factory. When all 16 production lines operate simultaneously at peak efficiency, the mathematics become astonishing. One complete electric vehicle every 30 seconds. It's industrial choreography executed at a scale and pace that would have seemed impossible just a decade ago. More than a factory, building a living community. Walking through this facility, you might expect the cold, impersonal atmosphere of a highly automated manufacturing plant. All steel, machinery, and mechanical precision. Instead, you find something entirely different, a functioning community where humans remain central to the operation. Over 60,000 employees work within this complex, but work doesn't fully capture the relationship. BYD has constructed comprehensive infrastructure throughout the factory grounds: employee residential buildings, primary schools for workers' children, medical clinics, fitness centers, recreational parks, dining facilities, and retail spaces. Employees don't face lengthy commutes through traffic. They can walk to their workstations in minutes. They remain on call when needed, yet they're surrounded by family, maintaining connection to their personal lives rather than being forced to choose between career and community. This design philosophy creates something psychological warfare specialists would recognize. It builds identity and belonging. When your children attend school on factory grounds, when your family lives in company housing, when your community consists primarily of colleagues, your sense of loyalty and commitment deepens dramatically. Employee turnover, a chronic problem in manufacturing, becomes significantly lower. Institutional knowledge accumulates rather than constantly draining away. BYD's vision extends well beyond current operations. By 2026, the company plans to expand the Zhengzhou facility's workforce to over 200,000 people. That's not a factory workforce. That's a population larger than many cities. The facility would essentially become a municipality in its own right, with all the complexity that entails. Strategic location. Why Zhengzhou? BYD's decision to construct this megafactory in Zhengzhou wasn't arbitrary. It was the result of sophisticated logistical and strategic analysis. Zhengzhou occupies a privileged position in central China, functioning as a major transportation nexus. The city's infrastructure includes extensive rail networks, highway systems, and aviation facilities that connect it efficiently to the rest of China and beyond. The highway network alone comprises hundreds of routes that blanket the entire central region and extend outward to China's coastal manufacturing zones and ports. The factory's proximity to Zhengzhou's international airport provides crucial advantages for time-sensitive shipments and just-in-time logistics. Products manufactured in the morning can be on aircraft bound for global markets by evening, dramatically reducing the time between production and customer delivery. But an even more significant development is approaching completion. Zhengzhou International Port, a $700 million infrastructure project covering 75,000 acres, aims to become a world-class inland logistics hub. As of May 2025, construction had surpassed 92% completion. When operational, this facility will enhance BYD's logistics efficiency considerably, potentially reducing transportation costs by at least 25%, savings that can be passed to customers or reinvested in research and development. Perhaps most importantly, the region surrounding Zhengzhou contains abundant mineral deposits critical to electric vehicle production. Lithium for batteries, cobalt for cathodes, nickel for energy density improvement, and rare earth elements for motors and electronics. Rather than relying entirely on complex international supply chains vulnerable to geopolitical disruption, BYD has invested in mining operations and processing facilities near the factory itself. This vertical integration provides significant advantages in cost structure, supply security, and pricing flexibility. The factory's presence has transformed the local economy. BYD's operation has attracted hundreds of supplier companies, manufacturers of components, raw material processors, logistics providers, and service companies, creating a comprehensive electric vehicle industrial ecosystem. This clustering effect generates substantial economic benefits for the region through employment, tax revenue, and economic multiplier effects. The local government recognized these opportunities early. Zhengzhou's municipal authorities signed strategic cooperation agreements with BYD, providing policy support, streamlined approvals, and financial incentives including research and development subsidies and tax advantages. This public-private partnership model has proven effective for both parties. BYD gained favorable operating conditions, while Zhengzhou secured major industrial investment and employment. Just as BYD was preparing to construct this superfactory, Western nations, led by the United States, began implementing measures designed to contain Chinese electric vehicle expansion. On September 13, 2024, the U.S. administration announced a dramatic tariff increase. Chinese-made electric vehicles would face 100% tariffs, effectively doubling their price in the American market. Shortly thereafter, the U.S. Department of Commerce proposed regulations that would prohibit smart connected vehicles, essentially all modern electric vehicles, from incorporating Chinese-manufactured software or hardware components. The stated justification invoked national security concerns, arguing that connected vehicles could potentially serve as surveillance tools or be remotely compromised. The strategic intent was transparent: create insurmountable barriers to prevent BYD and other Chinese manufacturers from gaining market share in Western economies, particularly in the lucrative North American market. These weren't subtle trade measures. They were explicit attempts to exclude Chinese electric vehicles from major markets. Yet these restrictions have not produced their intended effect. In fact, they may have accelerated BYD's push into other markets with even greater determination. Breakthrough in Europe. Overtaking Tesla. By May 2025, BYD achieved a symbolic milestone in the European market that, honestly, sent shockwaves through the automotive industry. Across 16 European nations, BYD sold 12,363 vehicles in a single month, narrowly surpassing Tesla's 12,264 units. This wasn't just a statistical anomaly. BYD maintained this lead for 2 consecutive months, signaling a fundamental shift in European consumer preferences. The detailed numbers really reveal the depth of BYD's European success. Pure electric vehicle registrations increased by an extraordinary 397% year-over-year. Hybrid vehicle market share exceeded 12%. These aren't niche sales figures or some kind of limited regional success. They represent meaningful market penetration in one of the world's most sophisticated and competitive automotive markets. European consumers, it turns out, respond to the same value proposition that attracted Asian buyers: competitive pricing, reliable quality, and increasingly sophisticated technology. As charging infrastructure improves across Europe and range anxiety continues to diminish, the barriers to electric vehicle adoption keep falling, and BYD stands ready to meet that demand. Global expansion, securing the future. BYD's leadership understands that sustainable growth requires more than just exporting from Chinese factories. True global competitiveness demands local production, reliable supply chains, and strategic resource security. The company has moved aggressively to secure lithium supplies, the critical element in battery production. BYD has acquired mining rights in Chile, which possesses some of the world's largest lithium reserves, and in Zimbabwe, where lithium deposits have recently attracted significant international investment. By controlling these upstream resources, BYD reduces vulnerability to supply disruptions and price volatility. In Europe, BYD is investing $1.3 billion to construct a manufacturing facility in Hungary. This plant will serve the entire European market, avoiding tariffs on imported vehicles while creating local employment and demonstrating commitment to European markets. Local production also reduces the carbon footprint associated with transcontinental shipping, which is, increasingly important to European consumers and regulators concerned about the total environmental impact of vehicle production. South America represents BYD's next major expansion target. In Brazil, Latin America's largest economy, BYD has committed approximately $600 million to construct a comprehensive production complex. This isn't just a simple assembly plant, it's an integrated industrial facility comprising 3 separate factories. The first will produce chassis for electric buses and commercial trucks. The second will manufacture new energy passenger vehicles. The third will process lithium iron phosphate battery materials, the chemistry BYD has specialized in developing. The passenger vehicle production line demonstrates BYD's strategic flexibility. It's designed to manufacture both pure electric vehicles and plug-in hybrid models, allowing the company to meet diverse customer preferences and varying levels of charging infrastructure development across different markets. When fully operational, the Brazilian complex is projected to produce approximately 150,000 vehicles annually. Perhaps most impressive is the construction velocity BYD has demonstrated. From initial groundbreaking to the first completed vehicle rolling off the Brazilian production line took just 15 months. This construction speed, itself a form of competitive advantage, reflects both sophisticated project management and the industrial expertise BYD has accumulated through rapid expansion in China. The broader implications: manufacturing paradigm shift. BYD's Zhengzhou Superfactory represents more than just one company's expansion. It really symbolizes a fundamental shift in global manufacturing dynamics. For decades, automotive production expertise and technological innovation were concentrated in traditional manufacturing centers: Germany, Japan, the United States, and South Korea. The assumption that this hierarchy would persist seemed pretty safe. That assumption has proven incorrect. BYD's achievement, manufacturing sophisticated electric vehicles at scale, with remarkable efficiency, at competitive prices, demonstrates that manufacturing excellence can emerge rapidly when the right combination of factors align: government support, capital investment, technical expertise, and ruthless execution focus. The integration of residential communities within industrial complexes, while raising questions about work-life balance and corporate influence that would concern Western observers, actually solves real problems in manufacturing operations: worker retention, rapid response to production issues, and deep institutional knowledge accumulation. The vertical integration strategy, from lithium mining to chip manufacturing to final vehicle assembly, provides resilience against supply chain disruptions that have plagued global manufacturing in recent years. When a single company controls more of its supply chain, it becomes less vulnerable to external shocks, whether those are natural disasters, geopolitical conflicts, or pandemic-related disruptions. Conclusion: the road ahead. The story of BYD's Zhengzhou superfactory encapsulates larger narratives playing out across the global economy. The rise of Chinese manufacturing sophistication, the transition from internal combustion to electric propulsion, the reorganization of global supply chains, and the complex interplay between technological innovation and geopolitical competition. Every 30 seconds, another electric vehicle completes its journey through this facility and enters a world increasingly concerned about climate change, air quality, and sustainable transportation. Each vehicle represents not just a product, but a statement about where manufacturing excellence resides in the 21st century. The question facing established automotive manufacturers isn't whether Chinese electric vehicles will compete globally. They already do. The question is whether traditional manufacturers can adapt quickly enough, innovate aggressively enough, and execute efficiently enough to maintain relevance in a rapidly transforming industry. For consumers worldwide, this competition delivers tangible benefits: more choices, better technology, and lower prices. For workers in traditional automotive manufacturing centers, it presents profound challenges as production migrates to new locations. For policymakers, it raises difficult questions about industrial policy, trade relationships, and economic security in an increasingly interconnected world.